Konnichiwa friends, my name is Aisman Samasi and welcome to day 3 of the deep learning practice. Okay, today we are practicing our neuron stacking, okay, for our day 3, okay. So I welcome you into this practice session. Also, just a reminder, if you don't understand anything, just check the lecture which was done in the previous video. You could also search on the internet and for the same problem and for the same type of problem you could also solve 5 problems to memorize it, okay. And there is also an optional is to do 5 push-ups as punishment, okay. So let's start our session, okay. First we must import the torch and the torch dot neural network for this session, okay. So now this section 1 part A, it is asking to create a torch class net A with linear layer input equals to 4 and output equals to 2, okay. So first we will be creating a class name named net A, okay, and it takes the nn.module. Then we make first function our init function which take our self, and here we initialize this super class here for our function, and here we have to make in one linear layer with input equals to 4 and output equals to 2, okay. So we make an initialize variable name fc1 which is equals to nn.linear, okay, nn.linear, and it will take input as 4 and output as 2, okay. Then we create our new function name forward which take x. Then here for x we will be getting our self dot fc1, okay, the first pass here, and then we will return our x, okay. By this case we initialize a torch class named net A, and we have one linear layer here, okay. So like if we will print this model, okay, net A, we will be practically getting here nn is not defined. I think this one have not run. Just a second. So here we see that we have our one linear layer in our in feature 4 and out feature equals to 2, okay. So this one is done. Now second question is to create a torch class net B with 2 linear layer, okay. So class net B with which take our nn.module, okay. Then first our init function with which takes self here. Then we call our super class here init, and then we need to create here 2 linear layer, okay. So first we name it fc1 self.fc1. we will be making it linear from 8 to 16. Then in next part we will be doing our nn.linear 16 to 4, okay. Here you have seen that here the out feature of the previous is equals to the in feature of the first, okay. So if you are going to today's lecture video, wait, I need to I think download the file here. You will be see that it's equal to this one, okay. the ruler dimension out feature of the previous layer should be equals to of the first layer. Okay, then here in forward we have to pass the value one by one. Okay, so first we will be passing the x with our first fc1, then with this x we are going to pass the x to fc2. Okay, and then we will return it. Okay, so when we will be printing the net b here, we will be getting this one. Okay, first linear over 8 to 16, then 16 to 4. Okay, and here the linear layer is done. Okay, what would happen if we had done this to 20 or like any random value? Okay, you will see that it doesn't affect during the initialization. Okay, but in our day 5 you will see that it will create a very big error. Okay, so for now let's throw it like this. Then here in C it's saying to create a torch class named netC with linear 10 20 followed by and dropout p equals to 0.3. Okay, so we create our class here, class netC, which take nn.module, then in our def / init we take our self, and then we initialize our super, then here we have to make first a linear layer which we say fc1, which will be our linear layer, and 10 20. Okay, then we will have our dropout layer, dropout equals to nn dot dropout. Okay, dropout, and its percentage will be 0.3. Okay, then we have our def forward function which will take x, then here we will initialize it by using our this one. Okay, we will be passing the value one after the other. Okay, so here x will be getting first linear dot fc1 x, then it will be under our self dot dropout. Okay, dropout, and then we will be returning this x. Okay, so when we will print this, you will see that it's printing the exact same thing. Okay, netC, I think main dot netC. Is there any error here? Self dot fc1 x, then self dot dropout, and then not module. Okay, so yes, you saw that finally the layer is created with our linear layer, then our dropout layer. Okay, with p equals to 0.3. So this question is done. Now the question where you have to create a torch class net d, so we name it net d, which will take our nn dot module, then we will make our init which takes our self here, then we call our super dot init. By the way, you could check also all the answer from here. Okay, here this will be available in this answer link. Okay, just in case if you don't know. So here we need to create a sequential layer with layer 5 to 10 to 1. Okay, so you must have known about sequential layer on how it work. Okay, it work as in stacking thing. Okay, so we name it self dot sequence. Okay, and here we'll be using nn dot sequential, and inside it we are having an linear layer with 5 to 10, then from 10 to 1. Okay, then in our dev forward, which will be getting is we will be using self dot sequence to pass our x, then we will be returning x here. Okay, then we will be printing the net d here. So you see that finally the layer is created with our first linear and the second linear layer inside our sequential. Okay, so by this way this question is also solved. Next it is saying to create a torch class net e that uses flatten then linear 28 cross 28 to 128. Okay, so we create our class name net e here, which import our nn dot module, then in our dev slash init, then we have here, then it will take our self, then we have to first use our flatten. Okay, so we create a variable name flatten, then we use nn dot flatten, and then we initialize our linear layer, which is 28 into 28, and out feature is 128. Okay, then in our forward, which will be taking x, then here we pass first our flatten here, so self dot flatten, and then we will pass our self dot fc1. Oh sorry, then we will be returning our x, then printing it. Okay, net e here. When we do it, we find that there's an init call. Okay, so here I forget the super dot init. So now it's done. Okay, we get our flatten and then our linear. Okay, so coming to our next question, name create a torch class netf where first it takes our nn dot module, then in our dev slash init slash which take our self here, and then we call our super function. Okay, then we have to create one linear layer and then a batch normalization layer. Okay, so we create our self dot fc1 as our linear layer, which take 128 in feature, and give 64 out feature, and then we have our batch norm. Okay, cell dot bn. Okay, nn dot batch norm 1d. Okay, one dimensional, and it takes our 64 here. Okay, then we make our forward pass here, which will take x. Then we passed our self dot fc1 with our x. Then we directly use our self dot bn. Okay, and we return our x. Okay, then we will be printing the net f here. Okay, then when we do, yeah, so this question is also done with linear and our batch norm 1d. Okay, now going to the second question, it is asking to create a torch class named netg. Okay, so we get netg which take our nn module here. Then we create our dep init function which take our self. Then we do create one linear, one dropout, and one linear. Okay, so we first do our supers dot init. Then we first create our first linear layer, name nn dot linear 32, in feature and out feature is equals to 64. Then we do here fc2, which is nn dot linear 64 to 10, and then we have our dropout layer. Okay, so we name it dropout, which is basically the dropout layer with 0.5. Okay, 0.5 dropout. Then we make our forward which take x. Then we use x here to first pass from the first linear layer. Then we make it pass through the dropout layer, and then we pass to our layer. Okay, and then we return the x here. Okay, when we print it, we get net g. When we print it, we could see that the net g is also done. Okay, now in section 2 we created towards class net edge using our end dot sequencer with our first flatten, then our linear, then also our linear. Okay, so we create a class name net edge which take our nn module. Then in our init function which takes our self here, then we call our super dot slash init here. Then we make our flatten layer, flatten, which is basically nn dot flatten flatten. Then we have our self dot first linear layer, nn dot linear 784 by 256. Then we have our second fc2 equals to nn dot linear 256 to 10. Okay, Then we make our forward function here, which would take x. Then we pass the x to first our flatten layer, so we call it self.flatten. Then we pass it with the self.fc1. Then we pass to the self.fc2. okay, then we return the x here. Then when we print it, net h, we get the required value here. okay, then we have to create a torch class net I with three linear layer. okay, so we make the class as net I, which take our nn module. Then we make our init constructor, which take our self. Then we first call our super dot init to initialize the super class. Then we have to create three linear layer. okay, this one we do inside our sequential. okay, sequential inside our sequencer, where we do the pass using 6 to 12, then our 12 to 24, and then finally 24 to 12. okay, so I you use here this sequential one. okay, now here we pass the entire x with the cell dot sequential, and we save the time. okay, return x is basically pure code hacking. okay, we could say we print it and we get the required answer. okay, now in J we create a torch class name net J, which take our nn module. Then we do our def init, which take our self. Then we create an super class, call our super class. Then we with linear 100 to 50, and then batch norm 1d 50. okay, so we create our cell dot sequential only to do it very quickly. Sequential and then dot sequential, and here we pass the nn dot linear 100 to 50, and then nn dot batch norm 1d. And here inside the forward we will be just returning the x directly. okay, cell dot sequential x here, and when we will be printing net J, we get the final here. okay, then we created torch class with net k. okay, class net k nn dot module. oh we then create our def init function which takes our self, then we call our super dot init here, then we had to call our dropout applied after linear. Okay, so we make here self dot sequential again, then we call our sequential, then we first make our linear which is going from 20 to 20 neuron, and then our nn dot dropout layer. Okay, dropout layer which will be 0.2%, and then we get our depth dot forward which will be getting x, then we pass on x, then we return the whole sequential layer. Okay, self dot sequential layer into x, then when we will be printing it, we will see the whole thing. Okay, wait, I think here net k, and here we say the sequential layer. Okay, then we create then we have to create a new torch class named net l nn dot module, and then we make our init construction here with which take our self, then here super dot init to initialize the super class. Then we have only 3 layers here now, 1 2 3. Okay, so we will do this with sequential only. Okay, self dot sequential self dot sequential, then we will be passing one linear layer named 3 to 6, then another linear layer named 6 to 9, and then final linear layer with 9 to 3. Okay, 9 to 3, then we pass the forward pass here which will take x, and then we return the whole sequential layer. Okay, self dot sequential x, then when we'll be printing the net l here, we'll be getting the 3 here is net l now, class net l, here the net l object, here the sequential, I think sequential. Okay, it's nn dot sequential. Okay, I forgot it, and here we get the 3 class here. Okay, so here we will end the video here only, as the left out question are exactly the same type. Okay, so just practice through the whole section here, and I will be seeing you in the next topic, which is basically about activation functions. Okay, tomorrow. For now, complete the whole exercise from here. Okay, it's also the whole same thing. You must remember that first you have to call the import torch, then you have to call torch dot neural network as nn, then we create a class with nn dot module which basically tells the thoughts that to track the weights and gradients automatically, and also to add GPU compatibility. Then we initialize our init constructor, where we initialize the neural network we will be using with our super.init, which is basically calling the super class here. Okay, then our dev forward function, which is basically all about stacking the neural network one after the other. Okay, so by this help you could solve here all the questions answer. Okay, that's all for today. Bye bye.